Assalamualaikum, my name is Zahir and I'm here today to present my individual learning outcome video for our group project, which is Zahir School 2030. Before I begin, allow me to briefly introduce our project. Zahir School 2030 is two-player cooperative VR game set in a futuristic cyber city. Player takes on the role of the scientist and engineer who must work together to restore four destroyed city pillars, defeat wave of enemies, fight boss, and become the savior of the city. This project wasn't about just building a game. This was about applying everything we have learned in this course, like game design, programming, networking, database integration, and cross-platform deployment, all at the same time, under real development constraint. It challenged us as individual and as a team in a way that classroom exercise alone cannot replicate. In this video, I will be sharing three things: what I learned from this project, the problem we faced during development, and how we solved them. I hope this reflection gives a clear picture of my personal growth as a game developer throughout this semester. Throughout this project, I gained three key learning experiences. First, I applied VR multiplayer game development technology by building two-player cooperative VR game using Unreal Engine 5 and the VR Expression plugin. This gave me hands-on experience with motion controller interaction, like saber combats, mechanics, and immersive 3D world space user interface, all of which are real application of current computer games technology. Second, I learned how to integrate a live game with real-time database by connecting Unreal Engine to Firebase through Node.js middleware server. I was able to synchronize play statistics, including points, currency, and health, across two separate VR devices in real time. This taught me practical network game data architecture that goes beyond what is typically covered in class. Third, I developed my ability to present and document a collaborative game project, working across three roles: designer, programmer, and artist, and presenting through a proposal, progress review, and final demonstration helped me understand how professional game development teams operate and communicate. Moving on the challenge encountered during development, the first challenge was a cross-platform compatibility. Our game needed to run on two completely different VR devices, Meta Quest 3 and Pico Pro 4. These devices have different hardware, different operating system, and different security configuration. Something that's worked perfectly on one device will fail silently on another, which made testing significantly more complicated than we expected. The second challenge was debugging in a VR environment. Unlike standard game development where you can use breakpoints and locks easily, debugging in VR requires us to build the APK, install it on the headset, play through the scenario, and then interpret what went wrong, all without being able to see the screen clearly. This cycle was slow and repeated many times throughout the project. The third challenge was multiplayer synchronization. Keeping the game state consistent between two players on separate devices in real time was harder than we anticipate. Action by one player need to appear correctly on other players' device immediately, and managing this across network environment require carefully planning and testing. For each of these challenges, we developed specific solution. To address cross-platform compatibility, we adopt a device-specific testing strategy. After completing each major feature, we test it separately on both headsets by isolating issue per device rather than assuming both will behave the same. We were able to identify and fix problem-specific bugs much more efficiently. For the debugging challenge, we use print string nodes extensively throughout our blueprint graph. Since traditional debugging tools are not available during VR headset testing, print string allow us to display real-time variable values directly on screen inside the game. This simple technique saves us an enormous amount of time and help us trace logic error quickly without requiring constant APK rebuilds. For multiplayer synchronization, we adopt a structure listen server networking architecture where one player hosts and the other connects. Variables that require creation across both clients were carefully identified and managed throughout the server, ensuring both players experience a consistent and reliable game state throughout the session. In conclusion, Zahir's Kodai 2030 was challenging but deeply rewarding project. It pushed me beyond classroom knowledge into a real-world game development problems such cross-device networking, database integration, VR-specific debugging, and multiplayer architecture. The challenges we faced were not obstacles; they were learning opportunities. Each problem required us to research, adapt, to make technical decisions under time pressure, which I believe is the most valuable skill this project has given me. I leave this project with a much stronger understanding of how modern multiplayer VR games are built, how systems are integrated at a professional level, and how to solve problems that do not have a straightforward answer. Thank you.